The word nebula is derived from Latin, meaning mist or cloud, and rightly so, as these objects appeared to be fuzzy and diffused to early astronomers rather than point-like in case of stars. This definition was adopted at a time when telescopes weren't as powerful as they are today, and thus lacked the resolution that is needed to study these objects in great detail. What you see here is the nebulous bubble blown by a O-type star. What is a O-type star, you ask? There is a wonderful video on stellar classification to understand this subject in detail, which I will leave a link to in the description of this video. However, here is a short summary. In the mid-1800s, stars were classified alphabetically based on the strength of their hydrogen adsorption lines. The stars with the strongest hydrogen line was classified as A. Then came the Bs with slightly weaker hydrogen lines, so on and so forth. It turned out that physically, this wasn't the correct way to classify stars. Then came along Annie Jump Cannon, who realized that stars were best classified based on their temperatures and came up with a Harvard classification scheme, which we use to even this day. The single most important plot in the whole of astronomy, which is the Hertzsprung-Russell diagram, is in fact derived from this classification scheme. According to this, O-type stars are the hottest class of stars with a surface temperature greater than 30,000 Kelvin. Starting from the hottest to the coolest, stars according to this classification are classified as O, B, A, F, G, K, M. This arbitrary string of alphabets can be remembered as O be a fine girl, kiss me, or based on your preference, the G could be swapped with a guy. Our Sun is a G-type star with a surface temperature of 5700 Kelvin. The O-type star in discussion here is thousands of times more luminous and some 45 times more massive than the Sun. The nebula itself is 7 light years across, that is about 1.5 times the distance between Sun and Alpha Centauri, our nearest stellar neighbor. Gas on the star gets so hot that it escapes into space as a stellar wind moving over 4 million miles per hour. This outflow sweeps up the cold interstellar gas in front of it, forming the outer edge of the bubble, much like how a snowplow piles up snow in front of it as it moves forward. As the surface of the bubble's shell expands outwards, it slams into dense regions of cold gas on one side of the bubble. This asymmetry makes the star appear dramatically off-center from the bubble, with its location in the 10 o'clock position in this Hubble view. Dense pillars of cold hydrogen gas laced with dust appear at the upper left of the picture, and more fingers can be seen nearly face-on behind the translucent bubble. The gases, heated to varying temperatures, emit different colors. Oxygen, for example, is hot enough to emit blue light in the bubble near the star, while the cooler pillars are yellow from the combined light of hydrogen and nitrogen. The pillars are similar to the iconic columns of the Pillars of Creation in the Eagle Nebula. As seen with the structures in the Eagle Nebula, the Bubble Nebula's pillars are also being eliminated by the strong ultraviolet radiation from the brilliant star inside the bubble. The O-type star forming the Bubble Nebula is formally known as BD plus 602522. An extremely bright, massive and short-lived star that has lost most of its outer hydrogen and is now fusing helium into heavier elements. The star is about 4 million years old, and in 10 to 20 million years it will likely detonate as a supernova, leaving behind a black hole as it is 45 times the mass of our Sun.